So in this question, question 38, what are isotopes of an element? What is the definition of isotope? So isotopes, they will have same protons and electrons, and they will have different neutrons. That is the definition of isotope. So atoms of and the condition atoms of the same element. So here it is atom of different elements, so it cannot be A or B. So either C can be an answer or D can be an answer because atom of the same element, which are having different number of what? They have different number of neutrons. So C is the right answer. Why D is wrong? Because they mentioned they have different number of protons. They don't have different number of protons. They have same number of protons. So when Rutherford bombarded a thin gold foil with alpha particles, so this was a Rutherford experiment as we already discussed, that what he did, he took a very thin gold foil or a metal foil and he targeted this metal foil by a fast moving alpha particle. And what he observed few of them deflected, few of them bounced back, and most of them are able to pass through. So he found some of the alpha particle were deflected through large angle. So why, like example, look, these are the observation. What are the observation? Number one, most part of atom is empty because most of the alpha particles are able to penetrate or pass through. That was first observation and conclusion. Second observation, that few of the alpha particle deviated there or changes the direction. And the third, that is due because of the charge is there, the positive charge of the nucleus or like charge or alpha particle and the nucleus have the same charge, and few of them bounce back, which means the matter is present or mass is present. So we have to explain, he found some of the alpha particle deflected through large angles, like the statement 2 and statement 3. Some of the alpha particle deflected through large angle or changes their direction. So what might be a reason why they changes the direction? So they changes the direction because the nucleus contain a charge, and they changes the direction because the mass is present in the nucleus. So most part of atom is empty. This is true, but that is not explaining why the alpha particle changes the direction. So A cannot be answered. When we check B, all the all of the positive charge, like there's a charge in the nucleus, and most of the mass is present or concentrated in the nucleus. That's why the alpha particles are changing their direction. So statement 2 and statement 3 are written together here in option B, that there is a charge that causes a deviation and there is a mass that causes a deflection or bounce back of the alpha particle. The third one, the positive charge in the gold atom is spread evenly. That is totally wrong. All the negative charge is concentrated at the center. That's also wrong, because in an atom we don't have the negative charge in the center. We'll always have electrons revolving around the nucleus. So there are three students. They are describing the structure of an atom. Student 1, what he said all the positive charged particles are present in the nucleus, like the protons are present in the nucleus. So that's true. Student 1 statement is correct. Student 2 said that the positive electron, how electrons are positive, electrons are negative. So that's student 2 is incorrect. Student 3 suggests the negative electron orbit the nucleus. So student 3 is correct. So which students are making the correct statement? So 1 and 3 are making the correct statement. That's why C is the right answer. Then question 39, when alpha particles are incident on a thin metal foil. So this is also related to Rutherford experiment, atomic structure. most of them pass through undeviated. Like, that is the first observation. What was the first observation? That when he target the gold foil with the alpha particle, he observed majority of the alpha particles are able to penetrate or able to pass through. So what he concluded from this, the atom has a dense nucleus. This statement is true, but that does not explain the observation. So observation that atom is mostly empty space or most part of atom is empty. That's why majority of the alpha particles are able to penetrate or pass through. So in question 39, a certain elements have several isotopes. Which statement about these isotopes are correct? So isotopes, they have the same number of the proton and they have the same number of electrons, but they will have different number of neutrons. So they must have different number of electron, that is wrong. They have the same number of neutron, that is also wrong. They have the same number of nucleon, they don't have the same nucleon number. They must have the same number of protons. So isotopes should have the same number of proton and different number of neutrons. So you can say same proton number, different neutron number, or same atomic number but different atomic mass, or the nucleon number. So D will be the right answer. So in this question, which row gives the relative charge of electron, neutron, and proton? Electrons, relative comparative charge, electrons are negatively charged, neutron, they don't have any charge, and the protons are positively charged. So what is the charge of electron? It must be negative, neutron should be neutral, and the proton should be positive. So it matches with option B, that electrons are negative, neutrons are neutral, and the protons are positive. So in the atomic model, an atom consists of a central mass and orbited by a much smaller particle. So there's an orbiting particle and the central mass is there. What is the name of the central mass and the orbiting particle? So the central mass is due to the neutron and proton, and what we call the central mass, we call that as nucleus. And the particles which are revolving around, which particle is revolving around, we call that as electron. So the central mass is a nucleus and the orbiting particle or the particle moving around, that is electron. So D is the right answer for this. So in this question we have uranium, which is 235, is a radioactive isotope. It undergo a chain decay, like emitting out particle eventually form the stable isotope of 207, and these two isotopes are present, represented as shown, uranium 235 and lead is there. During this chain of decay, how many proton and how many neutrons are lost? So how to identify? Basically, first we want to find the number of the neutron in uranium. So how many neutrons will be there in uranium? So it will be 235 minus 92, which is equals to 143. So 143 neutrons are there and how many protons are there? 92. Then in lead, how many neutrons are there? That will be 207 minus 82 is 125. And how many protons are there? That is 82. The question is how many neutrons are lost and how many protons are lost? Like in the beginning it was having 92 protons and then after it is having 82. So how many protons are being lost when 92 become 82? So means 10 protons are lost. And how many neutrons are lost? It was 143 become 125. So 143 minus 125, it means 18 neutrons are lost. So 18 neutrons and 10 protons are lost when uranium changes to lead. So a very important experiment improves scientists' understanding of the structure of the matter. The experiment involved alpha particle being fired at a gold foil. So, like there is a gold foil, and we target this foil by a fast moving alpha particles. We observe most of them passes through, few of them deflected, and few of them changes the direction. So basically what happened? That's the question. All the alpha particles were absorbed. That is totally wrong. They are not absorbed. All the alpha particles are undeflected. Not all of them are undeflected. That's also wrong, because few of them deflected as well. Some alpha particles were attracted by the neutron. Look, this is totally wrong, because neutrons are neutral particles. How neutron can attract the charge? Alpha particles have a charge, but neutron are the neutral particle. How neutral particle can attract the charged particle? So this statement is also wrong. Then the fourth statement, option D, some of the alpha particles are repelled by the proton in the gold atom. That is true, because when these alpha particles are moving towards the nucleus contain proton. So these alpha particles are repelled by the proton and they changes their direction. So which diagram represent the structure of neutral atom? Like which shows the atom to be neutral atom, the number of the protons should be equal to number of electrons. So when we check this one, this is A is having one proton and it is having two electrons, so it cannot be neutral. When we check B, it is having two protons, the center, and it is having two electrons, so it will be neutral. What about C? It is having two proton and one electron, so it won't be neutral. What about D? It is having three proton and two electrons, so it won't be neutral. So to be a neutral atom, it should have equal number of protons and electrons. So the question is, which diagram shows a possible structure of a neutral atom? Again, the similar question as the last one. So to be a neutral atom, the number of proton and electron should be equal. And proton should be inside the nucleus and electron should be outside that. Like when you check for A, the proton is, this is a proton, neutron are inside the nucleus and electron is outside, and number of the proton are equal to number of electrons. So A will be the answer. Why B is wrong? Because proton, neutron and electron all are inside the nucleus. That's why it is wrong. Why C is wrong? Because proton and electron are in the nucleus and neutron is outside the nucleus. That's why C is wrong. And D, proton is outside and electron and neutron are inside. That's why D is also wrong. So others are even, all are neutral because they have equal number of proton and electron. But the arrangement, the atom should consist of neutron and proton inside the nucleus, and around the nucleus there should be electrons. So scattering of the particle by a thin gold foil. So the question is, which particles are used? Provide evidence for a nuclear atom. Which particles are scattered by a gold nuclei, or which particles were used? So it was alpha particle. This is the symbol for alpha. So alpha particles were used for this experiment of a gold foil. So in this question, which statement is correct for a nucleus of any atom? The nucleus contain electron, neutron and proton. That is totally wrong. How nucleus contain electron, proton and neutron? Because nucleus is a central part, it contains neutron and proton, and around the nucleus electrons are revolving. So that's why statement 1A is totally incorrect. The nucleus contains same number of proton and as neutron. That is also wrong. Sometime it is same, sometime it is not. Like it's not valid for any atom. Nucleus has total charge 0. That is wrong. Nucleus contain a positive charge due to proton. The nucleus is very small compared to the atom. That is true. Like the size of the nucleus is negligible compared to size of an atom.